It's just a science project.
Silent breed is people!
You know, a doctor friend once said the same thing to me. Frankenstein was his name.
It's alive! It's alive! It's alive!
That sounds like something out of science fiction.
Please explain to me the scientific nature of the whammy.
We live in a spaceship, dear.
So? Yes, science!
Program complete. Enter when ready.
Hello and welcome to Science on Top, episode 222. Today is Sunday, the 16th of April 2016. I'm Ed Brown, and joining me today is Penny Dumsday.
Hello.
And Lucas Randall.
Hey.
And on the show today, we'll be talking about an ambitious plan to probe a neighbouring star system and pregnant dinosaurs. But first, Penny, perhaps you can help me with a problem that I'm having, because I really want to help scientists do some important work. But the trouble is, I also like spending all of my free time looking at adorably cute penguins on the internet. So how can I combine my two favourite pastimes?
Well, Edward, I'm glad you asked. So, there's a citizen science project called PenguinWatch 2.0, and I think we'll link to this on our various places around the web. And I've had a go at it. It's a study in Antarctica, looking at penguins to try and figure out what's happening with penguin populations and how they're being affected by climate change. What you can do, you can make an identity for yourself, log on. You need to look at photos and click on adult penguins, chicks and eggs that you can see, and if you can see any other organisms around, like humans or different kinds of birds. But if you see like a human, like it's usually a worker, you know, fiddling with a camera or something. And it's essentially just helping with a penguin census. So I did a few, and it's actually quite meditative and soothing. You just, you know, you're looking at, as Ed said, like really cute pictures of penguins. Sometimes they're not so cute, like it's night vision. It's a bit hard to see the penguins clearly. And identifying them.
So what do they need? I mean, presumably the researchers all already know what a penguin looks like. So this is just like to help them count populations and distribute. Yeah,
to help them count populations. I'm guessing this is something that you would think could be automated. But I think people, like we saw with some of the other citizen science projects, people are often quite good at seeing patterns and things when...
Yeah. Also, I think a computer doing this might have trouble because... Yeah. Penguins are kind of well camouflaged in the Antarctic. With the white and black, you get rocks and ice.
And it's kind of like, I was just about to say, it's sort of black and white penguins on black and white rocks and black and white ice and so on.
But okay, so I presume there's some sort of mapping involved in this as well, and you can see the populations moving from areas to areas and that. That'd be really cool. I can see why that would be useful then, for particularly, as we've talked about before, with climate change affecting how populations are migrating and things like that. And it's good to be able to help out.
And there's also, if you do get involved with it, there's a talk page where you can discuss with other volunteers, you know, what you've seen in a particular photograph. I found out some interesting facts about penguins, actually, from the talk page.
Bring it on.
So it said, what if I see a penguin that's covered in blood?
Oh.
And I was like, oh my gosh.
Zombie penguin.
Am I ever going to see that? Like dead penguins. Like, actually, you know what? It's probably not dead. So penguins eat, I think it was some kind of crustacean that has a really red pigment in it. And so all their poo is red. And that's where they get the pigmentation, this red pigmentation on their beaks.
So it's like if you see a penguin covered in blood, it's a penguin that's actually post-Christmas dinner ecstasy.
Yeah, pretty much. It's just had taken a big dump and...
Wow.
Yeah. I know, because I was thinking, oh no, I don't want to do this project if I'm going to see like penguins covered in blood. I can't deal with it. But yeah, there you go. It's probably just more disgusting.
Also, I'm looking at the article on Science Alert, and they've got a picture. I assume it's a screenshot from PenguinWatch. Do you also categorise the different types of penguins? Do you end up learning to be a penguin spotter, like a Gentoo or a chin strap or king penguin or whatever?
Look, no, not in the ones I was looking at. Okay. It just literally says, look, how many penguins and you click on adult or chick or egg. I didn't see any eggs. And once you click on if there's more than 30, once you click on 30 penguins, it says, all right, that's enough. Someone else is going to look at the picture, so don't worry if you've missed any.
Go outside and play with your friends.
Yeah, pretty much. But I found it quite enjoyable to do. Like,
yeah,
if it's a choice between clicking on penguins or playing Candy Crush, it's a similar.
That's a tough choice.
Well, I don't know.
No. Yeah, the penguins win for sure. I've done the things like Galaxy Zoo before, where you but then you get to a point that you start questioning yourself. At least with a penguin, it's either a penguin or it's not a penguin. I mean, you don't kind of like, is that a penguin? I'm not sure.
You don't
but
have
with
to go,
galaxies,
is it a barred spiral or an elliptical?
Right, you start to get a little bit self-conscious that you're going to classify something incorrectly. But I think it's fairly clear whether it's a penguin.
Well, sometimes there's like a penguin's back next to a rock. You think, is it a penguin or is it just a rock? But
well, there's also, I think they have built into these sort of things an error checking where the same image will be shown to 50 people. And if all of them identify something as a penguin, it's probably a penguin. But if there's a discrepancy, then it will work it out. Cool. So let's move on to the really big news this week, which was Stephen Hawking and billionaire Yuri Milner have made another big announcement. And you might remember last year the pair announced a $100 million initiative to seek out new life and new civilizations. Well, that operation started in January and it's already begun producing data. But this week they announced plans to send spacecraft to Alpha Centauri. Lucas, we're talking an ambitious plan to send a small probe to our nearest star system.
Yes. Yes, we are, Ed.
You were supposed to take on and enthusiastically
it just sounded like you were about to.
Right.
There was more to that sentence, but yes, that is correct. It is an ambitious journey proposed to our nearest star system. So Alpha Centauri is actually a binary system. If you look up at Crux or the Southern Cross, you can use Crux and the two stars of the Centaur's leg, which are known as the pointers. This one's actually the hoof of the Centaur, and you can use those two stars with the Southern Cross to figure out where due south is, which is kind of cool. Something I often show people in the sky. They go, yeah, good. But yeah, it's about 4.5 light years from us. So although close in cosmological terms, it's still a frickin' long way away. And using today's technology to be basically tens of thousands of years to get there, if we were to send something like the New Horizons probe.
An iPhone-sized probe would take 20,000 years. That's what I
right. So it's a long way. It's and a long time that it would take to get there, because when you think light takes 4.5 years to get here from Alpha Centauri, it's a long journey. However, this Yuri Milner, Mark Zuckerberg's involved in this as well, and as you mentioned, Stephen Hawking, and a few other, either eccentric scientists or very, very wealthy people are backing this. And the idea is to launch effectively a mothership filled with these nano probes, these tiny little things. And they did say sort of around the size and cost of an iPhone, which would then be released, one day, one at a time per day would be released, and then they would be thrust towards Alpha Centauri using laser beams. It just sounds absurd when you say it out loud. It really just does sound like a... Anyway, yeah, so the idea is that you would push these things. They would all have their own light sails, which would unfurl, and we've had very recently, which I've mentioned on the show before, a solar sail experiment that was very successful, which was crowd-funded. I was one of the proud participants of that funding, and I have a patch that I've sewn onto my thing. But anyway, that's another thing.
Onto your thing? What?
Onto a bag. I have a bag,
Okay.
like a satchel. Yeah, it's on that. And it's actually made me think I need more mission patches. So if you have any, send them my way. I'll pay you. Anyway, yeah, so the idea is that these iPhone size and, roughly the cost of iPhone probes would be released from the mothership once per day, and they would then use their own thrusters to get into position to then be, sent off in the direction of Alpha Centauri using these really, really, really powerful lasers that would shoot from Earth. They'd be somewhere very, very high, some sort of desert region that's quite high, because it would, you want it to traverse as little of the Earth's atmosphere as possible, and it would then thrust them in the right direction. And what they're saying, rather sensationally, is that these things could reach Alpha Centauri in somewhere between 20 to 30 years. 20 to 30 years. They would be accelerated to around a fifth of the speed of light to get there, which is just
I thought
amazing.
That was just astonishing. Like, I thought Alpha Centauri was just out of reach, basically, But, I mean, that's our lifetime. Like, it could happen before I die.
And that's the thing. I mean, Yuri Milner said this, to think that, a man who's in his 50s could actually see this happen in his life now is incredible. And it kind of made me think this could be one of those watershed moments. This could be one of those times where something very, very pivotal happened in terms of our understanding of our place in the universe. This might be that moment that people look back on, future generations, and go, this was the point at which we learnt our place in the universe. This is the point at which we decided finally to do something to figure out whether we're alone in the universe. I mean, that's friggin' awesome.
Where were you when we first got images back from Alpha Centauri?
Right.
Yeah.
So with the sensors that potentially, I should say, might be on these probes, the sensors would be capable of, for example, of making out continents on any planets that might be around the Alpha Centauri system. The Alpha Centauri system, just as a refresher, is known at this stage to be a trinary system. It has 3 stars. Back in the 1600s and something or other, it was discovered to be a binary system, not just one star. So it looks like one star when you look at it with naked eye, but you stick a telescope at it and look through it, and you can see it's actually 2 stars. But as it turns out, there's also a really, really small red dwarf there as well, and those 3 stars are orbiting each other. And strangely enough, there are some scenarios whereby a planetary system could form and remain relatively stable around 3 stars. It seems that there's 2 stars sort of orbiting each other, and then one that orbits the 2 of them. But what do we know? It's a long way away. But
I think a few years ago there was possible information suggesting that there was a planet there.
Yes.
So I think more recent studies have said that that's maybe unlikely. That's sort of been discredited a bit, but it's still a plausible. I
think for a long time it was assumed that it would just not be feasible for an orbit to be sustainable of planets within a trinary system. But when you look at the distances involved here, I mean, we still receive the occasional bump for the theory that maybe there's a what do they call it, nemesis star that impacts on the orbits of things in the Oort cloud and so forth. And last week, I think it was, or the week before, we talked about the potential of another planet that's out there, Planet 9, which for which evidence is mounting that there's definitely something there that's causing some orbital resonance to occur. So, there's freaky stuff that we just don't understand, and that's what I love about this is every to think that only a matter of months ago we were marveling at photos of Pluto that my whole life, in fact, your whole life, everyone, all of the listeners' whole lives, we've only known Pluto as a blob, and prior to that a speck of light. Now we've got fairly high resolution photos of the surface of this planet. Now we're talking about something that could launch really within the next 20 years, that could then reach this orbit within the next 20 to 30 years after that. And Yuri, for example, was talking about how for him to experience this and be a part of the discovery, he would also be relying on some fairly big advances in human health and maintaining life. So hopefully that occurs for Yuri. But I'm younger, so hopefully I'll be there anyway. But it's so cool to think that we're at the point now. And one of the videos that I watched for that was on one of the stories here, which I've included in the links, was talking about, I think it was Stephen Hawking was talking about, that we've reached a point by which this is no longer science fiction. This is no longer fantasy. We actually have the technology now to do this. It's just a matter of having the will. And it's no longer impossible, it's just difficult. And we've done things before that were very, very difficult.
So let's talk about that technology. Let's talk about that technology, though, because I'm still confused. I mean, I like the idea of it kind of borrows a bit from Stargate Universe with having the seed ships where the mothership will drop these little probe ships out every day or every few days, whatever. But so what's the thought then? You have this trail of several probes heading in the same direction.
We're not talking about several probes. We're talking about hundreds of probes. Hundreds of probes. And the idea is that you spread your risk and you spread your expenses. So if a few of them get hit by space debris or they, happen to get in the path of a comet which causes them to be perturbed or whatever, it doesn't matter because you've got hundreds of the things heading there. It also means that the bump that you have to give them with the laser isn't so large because there are many, many of them and they're quite small. So the idea here really is just spread your risk, spread your load. You get a very, very intelligent payload with microcomputing involved to give you something that you can do real science with. We're seeing this already. We're now seeing citizen science in the hands of school students where they're launching micro probes that are really the size of like a mobile phone, and they're doing some really cool stuff with it. And that's just
CubeSats.
Yeah, and this is on the back of, as I say, the recent light sail project where we've proven that yes, you can in fact unfurl a sail and you can catch this, the solar radiation to basically photons pushing you along the way. This is the same sort of process, but much, much bigger, because now we're not talking about using the sun's photons. We're talking about using really, really concentrated photons being sent from Earth. And the cool thing about that is once these things are in position, it's just a matter of lining them up, and if you shoot them with a laser on the right trajectory, they're going to head straight to where you want them to go. So it's just a matter of knowing, okay, this is what the travel time is going to be. Therefore, if we accelerate them for 2 weeks, for example, they're going to reach this particular speed, and then they'll get sort of beyond the range of the lasers being able to do much, because even lasers being focused will still disperse over time. But then they're going to maintain that speed because nothing slows them down. It's not like they get slowed down by friction or by air pressure, because there isn't any. So once you get them to speed, they'll get there.
Very cool. And of course, once they get there, then we've got to wait 4.3 years for the signal to get back saying they've arrived. So. Which
is nothing. But I mean, you compare that. If you remember, do you remember the trepidation with which you and I sat there and waited for the return signal from Mars when Curiosity landed? Did it survive? And that was a matter of minutes. Can you imagine what it would be like for 4.5 years? But if you've spread your risk and you've got 400 of the little buggers going over there, you've got a really good chance of getting them back. The first thing that occurred to me, though, of course, is so we've got 400 of these things. That's great. They're going to reach there. But how do you get a battery that's capable of sending a signal 4.5 light years onto something so small? That'll be interesting to think of.
Would you need a battery? I mean, there's 3 suns there. I suppose a small solar panel on it.
True. Yeah, a solar panel might be the go, but it's still, a solar panel is a matter of area. You're talking about catchment area to convert the photons to usable energy. So we're talking really, really small devices here. So I don't know. Maybe you would use the solar cell itself.
The origami solar panels getting developed that fold up and unfold.
Yeah, and as I say, you could maybe integrate that with the solar cell itself, which could give you potentially a very large catchment area. So either way, they're cool.
That by the time this launches, we'll have very good batteries that can power your phone for a whole day even.
No, Ed, don't talk crazy talk.
So who knows what they could do with a probe in another solar system.
Maybe their new smartwatches could go for a whole week. It'd be unthinkable.
All right. Well, let's finish off then, I guess, Penny, with a paper published in the Journal of Scientific Reports. And it's all about how to determine if a dinosaur was pregnant when it died 70 million years ago. It's really cool.
It is really cool because I was thinking, oh, well, you just look for the eggs. But of course, you don't always get that opportunity. You don't always have a whole skeleton. You can't look for eggshells everywhere. So how can you tell if a dinosaur is about to lay eggs? And something that I often forget is that birds are essentially dinosaurs. They are completely descended from dinosaurs. So when we're looking to understand dinosaurs, it's good to look and understand birds. And when a bird is producing eggs, the bones, or well, I should say her bones, because it's always a female bird, develop a temporary new kind of tissue called medullary bone. And it's kind of a spongy looking bone, and it fills in the cavities that bird bones have. So I'm not quite sure why they develop that tissue in their bone, but they do. And it's been hypothesized that maybe dinosaurs do this as well. And it's been found in 70 million year old fossil bones of a T-Rex. And just by looking at the bone, it really did look like this medullary bone. And this was an 18-year-old female, presumably T-Rex dinosaur. However, to rule out other causes of this particular appearance, they tested for a substance that's found in birds in that medullary bone, keratin sulfate, and that was found in the T-Rex bone, which really suggests that this is a way we have that this trait of birds was inherited from dinosaurs. It's not a new evolution. And that what that can do is it's not just interesting because you can say, oh, hey, this particular dinosaur was pregnant, but it means that by analysing bits of bone, you might be able to tell, okay, well, these skeletons were of female dinosaurs. We know that they were female because they were about to lay eggs. They have these features, and we can extrapolate that to other skeletons. So we might be able to understand a little bit more about dinosaur societies. I don't know.
Well, no, it's useful even just for identifying skeletons, because you might have a slightly smaller T-Rex skeleton. Does that mean it's a different species or something, or is it a female version of it? Or it could be a larger, we don't know.
Or you might see that all the ones that you know are female because of this medullary bone also have, I don't know, some like knob on their skull.
Or big childbearing hips.
God. Or something like that, which is a real tell for femaleness that you can look for in females that aren't about to lay.
Very cool.
So I thought this was really cool. I love the amount of detail that we can find out about, something that lived 70 million years ago.
And just from a few fragments of bone. Yeah. I think that's our show. And as always, we'll have more information for everything we talked about today at scienceontop.com/222. And you can also find our social media links and ways to get in touch. Leave some feedback. You can email us, feedback@scienceontop.com, and we really appreciate you leaving a review or a rating on iTunes. Thanks for another great show, Penny and Lucas.
Thanks, Ed.
Always a pleasure. Thanks, Ed.
This episode was edited with dexterity and creativity by Marcos Benamou. And thank you everyone for listening. We'll be back again next week, putting science on top of the agenda. Join us then.
We are here today to talk about breakthrough Starshot and our future in space. What makes human beings unique? There are many theories. Some say it's language or tools, others say it's logical reasoning. They obviously haven't met many humans. I believe what makes us unique is transcending our limits. Gravity pins us to the ground, but I just flew to America. I lost my voice, but I can still speak thanks to my voice synthesizer. How do we transcend these limits? With our minds and our machines. The limit that confronts us now is the great void between us and the stars. But now we can transcend it. With light beams, light sails, and the lightest spacecraft ever built, we can launch a mission to Alpha Centauri within a generation.